Alright, today we're also going to be talking about orbitals and orbiting bodies. We're also going to be talking about angular momentum and how that relates to orbiting bodies. So first of all, we know angular momentum is represented as L is equal to mv times r. R is the radius, mass, velocity. So here we have orbiting a certain object orbiting something else here. So let's calculate the angular velocity for this outer object. Let's say the mass is 2. So 2, velocity 3 meters a second. So times 3. And then the radius is 2. So that would give us 2 times 3 is 6. 6 times 2 is 12. So the angular momentum would be 12 in this case. But let's go back to that problem we solved in the previous video, and let's see how the total momentum, angular momentum of the system. So here we have the two orbitals, the center object, satellite 1, satellite 2. So the thing about momentums is you can easily add them together. So all we have to do is take the momentum of the first one and then add it to the momentum of the second one. However, momentum there is no negative version of a momentum. Something can't have negative momentum. It's not directional, so that means we're going to have to use the absolute value. So let's call this one mass 1 and then this one mass 2. So to find the total angular momentum, we're going to have to add mass 1 times velocity 1 times radius 1. Now we're going to add that to mass 2, velocity 2, and radius 2. And we're all going to put that in absolute value so that we can get a positive value. And that would give us answer C.